Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And before we get into today's podcast, we want to remind you all again that we are launching our new book. So all of our Tyrannosaurus patrons by August 21st are going to get a signed physical book as long as the address is updated. And everybody who wants to get involved with our book launch should fill out our form at bit.ly/dinosaurbookteam, all lowercase. This week, in our 244th episode, we have a bunch of news, including a new survey of all Hell Creek dinosaurs, a list of sauropods from the Morrison Formation, and some new paleo pathologies. And of course, we have a dinosaur of the day, and this week that's Sinornithosaurus. But before we get into that, we want to thank some of our patrons, and this week we'd like to thank Lucas and Eli, Wyatt, the Georges family, John Heck, Ranger Chris from Dino for Hire, Ray, Oliver E., Andrew and Helena Webb, Callum, Ricky, William, Red Sox Rex, Wouter, Chirac, Moss Utah Raptor, and Lanasaur.
Yes, thank you so much to all of our patrons. We really appreciate all of the support and being a part of our community, so thank you. And if you want to get a signed copy of our upcoming book, then check out our page at patreon.com/iknowdino.
Jumping into the news, we have a new census on dinosaurs from the latest Cretaceous of the U.S., and it was written by Walter W. Stein and published in the Journal of Paleontological Sciences, which I don't think we've ever mentioned before. It's a really interesting, very small journal that is published by a, quote, professional association of commercial fossil dealers, collectors, enthusiasts, and academic paleontologists, end quote. So I'm wondering if they published in this journal because they include a lot of private fossils. So maybe, I don't know if other peer-reviewed journals would allow them to publish on those finds. Might be why they picked this sort of niche, interesting publication. But in any event, it built on a lot of previous census studies, and they said that they spent about a year going through online databases and interviewing curators and collections managers to try to find basically all of the dinosaurs they could possibly get their hands on from the Hell Creek and Lance formations.
That sounds ambitious.
It is, yeah. Fortunately, that similar things have been done in the past for more targeted ranges, like looking for all of the fossils by Barnum Brown and things like that. So there's a good starting point. And I should mention that both the Hell Creek and Lance formations are from the latest Cretaceous, and they're actually both named after creeks. Sometimes Lance Formation is called the Lance Creek Formation. But the Lance Creek is in Wyoming, while the Hell Creek is in Montana. But the formations also extend into the Dakotas, and they're both Maastrichtian, is what I mean by latest Cretaceous, right as the dinosaurs were going extinct, basically, and then a couple million years before as well. In all, they listed 653 skulls and partial skeletons. Just over half, 335, were from Triceratops.
Oh, wow. Seems like that could help with that debate.
About Triceratops versus Torosaurus?
Yeah.
Yeah, if there are 335, that's a lot. I'm not sure how many of those are skulls versus partial skeletons.
Right, and also how many are from private collections.
Yeah, and how good the records are about like the stratigraphy, so we know if it's what age it's from specifically.
Mm-hmm.
But I'm guessing the reason they have so many is that their skulls fossilize pretty well. It seems like Triceratops can't really eat them. I think it's helpful. And I don't think that they're assuming that most of the animals from the Hell and Lance Creek were from Triceratops. I think it's more of a, this is what's in museums kind of thing.
I see.
As far as other dinosaurs, which were found from skulls and partial skeletons, hadrosaurids were the next most common with 149. Tyrannosaurids had 71. Basal ornithopods had 42. Pachycephalosaurids, 18. Ornithomimids, 13. Oviraptorosaurids, 9. Ankylosaurids, 6. And Nodosaurids, 6. And then just one dromaeosaurid and one troodontid. I think that dromaeosaurid is probably Dakotaraptor. But it really makes you appreciate just how common Triceratops and really Edmontosaurus is the hadrosaur we're talking about for the most part there are compared to ankylosaurids and other dinosaurs like Pachycephalosaurus. In addition, so that was the one category, the skulls and partial skeletons, they also referenced, quote, over 41,800 isolated bones and teeth, end quote. So obviously that's a lot more of the material that's been found, but it's not quite as diagnostic because if you're just finding teeth, you can't do a lot with that information. 46% of those bones, though, were from hadrosaurids, as they put it, quote, usually identified as Edmontosaurus.
Cows of the Cretaceous.
Indeed. Or maybe the horses of the Cretaceous.
Oh, right. Depends on who you talk to.
Yeah. Only 21% were from ceratopsids, and they said that that was generally identified as Triceratops. And so that kind of flips the two most common taxa between the two. The most of the skulls and partial skeletons were from ceratopsians, but most of the individual bones were from hadrosaurids. So it's a little bit hard to say which one was more common generally. Kind of seems like Edmontosaurus maybe, and that ceratopsian skulls just preserved really well, but it's hard to say. The author also notes that collection bias might play a big role here with the popularity of Tyrannosaurus and Triceratops skeletons and skulls. So even though they found 71 tyrannosaurids, and it's like, wow, that's more than they found basal ornithopods, that's a crazy number. But really, it's probably if you find a bone from a Tyrannosaurus, you're not leaving it in the ground. You're going to dig it up. Whereas if you find an ornithopod hip, you might just leave it there and move on to something else. Another interesting note that they made in the paper was that very few small theropod skulls and skeletons were found, but tons of their teeth were found, on the order of thousands of them. So this might be a preservation bias as well towards larger animals, because sometimes, unless you're in certain areas like China, where they get all of these bird dinosaurs found, it can be really hard to find smaller dinosaurs or even mammals or other small animals in general in the paleontological record. But teeth do tend to fossilize a little bit better, and we can tell there are a lot of them there based on all these teeth. And therefore, we might assume that the Lance and Hell Creek environments weren't just big dinosaurs, and that there might be lots of unnamed smaller dinosaurs yet to be discovered and named.
If there was a niche to be filled, there was probably an animal to fill it.
Yeah. And in the Mesozoic, it was a lot of dinosaurs in all those niches.
Mm-hmm.
There's also a really interesting table in the paper breaking down where the information came from. They categorize the different places that hold fossils as public museums and universities, foreign museums, which I think means not in the US, local museums, private collections, and commercial collections. And the most interesting thing to me was that private collectors seemed to be quite willing to share information. They actually had the highest response rate for a complete census of what they owned. 71% of those contacted provided a complete census, and the lowest rate actually came from commercial collections, with only one complete census from 11 places contacted.
Interesting.
Yeah.
I wonder why.
I'm guessing it might have to do with the nature of this organization, that it involves a lot of these private collectors. So they might already have the contacts with them. And
so they're willing to open up.
Yeah, exactly. And in the supplemental material, they're almost all listed as anonymous.
Mm-hmm.
So I think they promised that kind of level of anonymity, and they were willing to share information. And then there were also many partial responses and others who didn't share information in every category. So of the 170 different organizations and groups who have Lance or Hell Creek dinosaur fossils, they found contact information for only 140. There were 30 that they either couldn't find information for or didn't contact.
It's still a lot.
Yeah, but they only got information from 97 of them. So that still leaves a very large group that didn't give the information, or they couldn't get the information from. Some of them did have online databases, some of those 97. Others gave rough estimates, and then everything in between. So there's a varying degree of how much information they got. And then the supplemental material also gives a list of all the known Lance Hell Creek fossils in each collection, as well as collections that they know of but couldn't contact.
Oh, that's great for anyone who wants to study these things.
Exactly. It's ripe for a follow-up study. And there are lots of comments like, quote, did not return emails or phone calls, end quote.
Yeah, well, they tried.
I think it's just kind of funny because it has the name of the institution, and then it's like, they wouldn't talk to me. But they did mention in the article that a lot of them were either in the process of recataloging their entire collections, or otherwise working with things, or just overwhelmed with other projects, so that they didn't have time to answer his requests. But they still had a collection of thousands of data points to work with. And I think it's pretty interesting to see all of these different museums all over the world that have fossils from such a small area in the US.
So there seems to be a lot of census things going around, because Emmanuel Shop and others have published a free online spreadsheet of sauropod specimens from the Morrison Formation, so basically a census. This includes a lot of information like where they're housed, localities, lots more. So dinosaurs have been dug up in the Morrison Formation for more than 150 years, and sauropod specimens are housed all around the world. That can make it hard to keep track of what bones are where. So to make research easier, the authors made a spreadsheet. And this spreadsheet has been in the works for 10 years, so it's really fleshed out. It lists 3,226 specimens from more than 60 institutions on 6 continents. They're never expecting the spreadsheet to be complete, but several sauropod specialists are contributing and curating. The authors say that they hope this project may, quote, inspire other efforts to compile and publish similar spreadsheets for different taxa, geological units, and geographic regions, end quote. I wonder if the people involved in the census of fossils from Hell Creek and Lance formations knew about this one.
Yeah, I mean, it was a little bit different because theirs was all kind of categorized. They didn't break down specific individuals or specimen numbers, which is a little unfortunate. But it would be really nice to see that sort of granularity with Hell Creek.
Could be a first pass.
It's true.
Well, so the sauropod spreadsheet, like you said, gets very granular. So they have columns for taxonomy, specimen number, as well as records of where they've been housed in cases where fossils were transferred to multiple museums and then the specimen ID changed. Contents, which are the single bones that are preserved. References to any studies that mention the specimen. And I think 3D prints or 3D modeling. Ontogeny, the general size and assessments of histological ontogenetic stages. Locality, these are the quarries and localities that have been published, and that doesn't include GPS coordinates for a few reasons, basically trying to protect fossils from getting poached. There's also stratigraphy, the current repository, and further info. And in the future, the authors want to add links to references and combine new information. So qualified researchers who want to contribute can contact Emmanuel Shop and be added as an editor. It's a pretty cool, very collaborative project.
I can see why you like it so much. It's just a giant list of sauropods. What's not for you to like?
Nothing. Absolutely nothing. More information, please.
I like it too. I always like being able to see where these specimens end up because a lot of times when we're talking about a new dinosaur, I end it by trying to figure out where I might be able to see it. And sometimes even in the original paper describing it from 2019, they don't even really tell you. Like you can usually guess based on the institution name that's attached to the specimen number, but sometimes it's already moved. So it would be really helpful. The best thing would be if we had a database of all of the dinosaur fossils and where all of them are.
Sure.
In just one central place.
But you got to start somewhere, so it might as well be with sauropods.
Yeah. Maybe we can get a whole bunch of these individual ones and then someone will be like, yeah, let's put them all together. And then we'll really have something good.
Baby steps.
So on to paleopathologies. And I should warn that this is a little bit graphic because we're talking about severe injuries to a dinosaur. And a lot of them involve like broken bones and how they formed and infections and things like that. So if you're sensitive to that sort of thing, you might want to skip this one. But we love paleopathologies because they're fascinating. And I think they're a great window into how dinosaurs were living creatures and had to deal with all sorts of rough stuff. They weren't just these big, invulnerable creatures that got to do whatever they wanted and never had to deal with any consequences. So this specific article was written by T.C. Hunt and others and published in Scientific Reports. And it's about a subadult Tenontosaurus from the early Cretaceous. And it's an ornithopod, if you're not familiar with Tenontosaurus. It's often depicted being eaten. It's sort of the life of a Tenontosaurus. It's herbivorous, and at full size, they were about 7 meters or 23 feet long. I'm not sure how big this one was because it was a subadult, so it may have been a little bit smaller. This specific individual was collected in 2001 in Oklahoma, and they found a total of 5 paleopathologies on it. Or I guess I could just say pathologies, because obviously if it's a dinosaur, they're paleopathologies. The first one is that the left toe and left rib, quote, are both fractured with extensive callus formation in later stages of healing, end quote. And a callus is a normal part of the bone healing process. So the fact that it was there meant that the dinosaur had at least started the process of healing. It didn't just die from these injuries. Another left rib, as well as a right rib, have, quote, impacted fractures, end quote, which shortened them both by about an inch. And I had to look up what an impacted fracture is because I'm familiar with lots of types of fractures, like compound fractures and things. But an impacted fracture, unfortunately, is exactly what it sounds like. It's basically an impact that simultaneously breaks and then jams the two parts of the bone together, sort of like a telescope.
Ouch.
Yeah, it sounds terrifying, and I didn't know this was a possible thing that bones could do, but apparently it can happen. And like I said, it shortened both of the ribs by about an inch. So an inch of the end of the rib got jammed into an inch of the other part of the rib. Pretty gnarly. The authors say that all of these pathologies are consistent with a fall. So I guess what happened is it fell, it injured its toe, a rib, and then two of the ribs actually got broken and kind of jammed up. So it must have fallen kind of down directly on those ribs so that they broke and then got shoved. Anyway, if you're counting, I've only listed 4 pathologies so far. Number 5 is the toe and rib that have a callus appear to have a, quote, post-traumatic infection in the form of osteomyelitis, end quote. And osteomyelitis is a bone infection, is what that means.
Yikes.
In this case, one of the infected bones in the foot has a Brody abscess, which is a first for an herbivorous dinosaur. I think it was only the second one ever known in a non-avian dinosaur, so that's exciting. If you're wondering what a Brody abscess is, it's a type of bone infection usually caused by a bacteria that generally stays inside a single bone. So it's not like the worst type of abscess.
Right.
In fact, they're kind of hard to diagnose in people because people also get these, and they tend to be, at least in people, in our leg bones. And in this case, they think that the bacteria came in through its blood and then sort of spread into the bone. In humans, I think they said that it takes between months to up to 10 years to heal, but it's not a chronic condition, so it does heal eventually, but it's just kind of a infection you get, you might not know about it, and then it heals slowly. I think they're quite rare in humans. They referenced maybe 25 cases that they knew about, but since it's inside the bone, like, why would you even know it was there unless it was causing pain for some reason? And then it's hard to diagnose because it's buried in there. Anyway, the Tenontosaurus didn't die immediately from the fall because we saw that it has those calluses forming from healing the bones. But they think that the fractures would have caused chronic pain, while the Brody abscess seemed to get kind of bad, and it might have caused it to limp, which put together meant that it would have needed extra food to fight the infection, but its injuries would have made it harder to get around and gather food, and eventually, quote, resulting in malnutrition and a suppressed immune system, potentially leaving it susceptible to greater secondary infection, end quote.
Catch-22.
It is. You get infected, so you need to eat, but the infection is preventing you from getting to the food, which is making the infection worse. Not great.
Poor dinosaur.
Yeah. Tenontosaurus cannot catch a break.
Moving on from that lovely note. In totally different kind of news, paleontologists from Colorado Northwestern Community College, along with the Colorado Division of Fire Prevention and Control Montrose helitack crew, worked together for wildland firefighter helicopter training, and they also used the helicopter to pick up Walter, which is a dinosaur that was found in Colorado in 2014. So they lifted 2 plaster jackets that weighed over 1,000 pounds each and transported them to the community college's Craig campus. Walter is named after the Great Dane Walter, who belongs to the Ellises, and Walter the Great Dane is the one who found the leg bone of Walter the dinosaur. So now students at the community college will be able to clean the fossils and study them.
Nice.
Also in Colorado, but in Wolcott, there's a new dinosaur museum that opened up. Admission's free, and this museum means that there's now a museum in between Denver and Fruita, Colorado.
They have so many dinosaur museums.
Apparently not enough. I don't know if you can have enough.
Yeah.
Next, thanks to Daniel, who shared this one with us. So on September 15th, animatronic dinosaurs are going to be at the Bath Racecourse in the UK. There will be a T-Rex, raptors, and baby dinosaurs, and visitors can learn about dinosaurs and do ranger training where they can learn, quote, what to do in an emergency dinosaur breakout situation, end quote. Which could happen, with birds.
Yeah.
So kids under 18 can go for free.
And birds that have been kept in cages might be extra angry.
Yes, especially cassowaries.
Oh, no. Rampaging cassowaries are not something I want to see.
No. In Las Vegas, Springs Preserve has a new exhibit called Dino Might, which is on display from now until September 22nd. And it's a custom mural that shows strong dinosaurs and, quote, things they might say or do while stomping through the preserve, end quote. Sounds intriguing. The Science Museum of Minnesota recently had their first Dino Fest, and that included a life-size T-Rex puppet, live animals, and talks from experts. And it sounds like this was going to be an annual thing. One of the experts at the event was Dr. Alex Hastings. We interviewed him back in episode 167, Tenontosaurus, if you're interested in listening to that. And Alex is the new Fitzpatrick Chair of Paleontology at the Science Museum, so congrats, Alex. And last, 2 Chinese paleontologists have made a complete rendering of Auroraceratops based on articles that appeared as memoir in the Journal of Vertebrate Paleontology. So Auroraceratops was a basal Neoceratopsian. It was named in 2005 based on a skull, and since then more than 80 individuals have been found. So that probably is why they decided to render it. And this rendering shows Auroraceratops walking on 2 feet, and can help scientists better figure out the changes between bipedal and quadrupedal dinosaurs.
And before we get into our dinosaur of the day, we want to remind everybody that we are launching a new book, and that means 2 important things. All of our Tyrannosaurus patrons are going to get a signed physical book mailed to them as long as their address is updated by August 21st, and anybody else that joins by August 21st at the Tyrannosaurus level can also get in on this signed physical copy of the book, something that we almost never do. It's a very special occurrence.
Yep, for a special book, 50 dinosaur tales.
Yep. And for those of you who are not at the Tyrannosaurus level, or I guess if you are, and you want to help us launch the book, you can head over to bit.ly/dinosaurbookteam, all lowercase, by August 5th, and you will get a digital copy of the book, and you can help us to launch the book by either leaving reviews or helping us to promote the book, which in turn will hopefully help us grow the podcast. That's the dream. So either way, please consider joining the Tyrannosaurus level, updating your address, or joining our dinosaur book launch team by going to bit.ly/dinosaurbookteam or patreon.com/inodino for the Tyrannosaurus stuff.
And now for our dinosaur of the day, Sinornithosaurus, which was a request from Thieving Raptor Lorenzo via our Patreon/Discord. Another benefit of being one of our patrons is you can request a dinosaur. Sinornithosaurus was a dromaeosaurid that lived in the early Cretaceous in what is Liaoning, China, in the Yixiang Formation. It was a basal dromaeosaur, and it helps show that earlier dromaeosaurs were more like birds than later dromaeosaurs. Sinornithosaurus was small, about 3 feet, 1 meter long, though Gregory Paul estimated it to be 3.9 feet, 1.2 meters long, and weigh 6.6 pounds, or 3 kilograms. It had feathers similar to Archaeopteryx. There were preserved impressions of feathers found on the whole body and forming the wings. The feathers looked the same as feathers found on birds from the same area. Sinornithosaurus had 2 types of feathers, one type like modern down feathers, and one type like modern bird feathers, though they looked a little different from flight feathers. There was no continuous vein. It had different colored feathers around its body. A 2012 study found that they were reddish-brown, yellow, black, and gray. It may have been able to glide short distances after jumping from trees. In 2018, McNamara and others analyzed the fossilized skin of Bapiosaurus, Sinornithosaurus, Microraptor, and Confuciusornis, and they used electron microscopes to study their fossilized dandruff. This helps show how dinosaurs shed their skin. They found it to be nearly the same as to dandruff in modern birds. Sinornithosaurus shed its skin in flakes like modern birds and mammals. It didn't shed all at once like a lizard or other reptiles. And they found that feathered skin had evolved many, but not all, modern attributes by the time Maniraptorans came about in the Middle Jurassic. This shows evidence that early birds and dinosaurs were evolving skin in response to having feathers. The fossilized dandruff is made of corneocyte cells, which when alive are dry and full of keratin. Modern birds have fatty corneocytes with loosely packed keratin to help them cool down quickly when flying for long periods of time. The fossilized skin had packed keratin, which may mean the dinosaurs didn't get as warm as modern birds, possibly because they either couldn't fly or couldn't fly for long periods of time. Sinornithosaurus was carnivorous. It probably ate small animals. It had a sickle-shaped toe claw, and it may have been cathemeral, which means active throughout the day and night in short spurts. It was described in 1999 by Xu Xing and others. They found an almost complete fossil with feather impressions. The type species is Sinornithosaurus millenii, and the name means Millennium Chinese bird lizard.
I like bird lizard as a description of dinosaurs.
Yeah, best of both worlds. The second species is Sinornithosaurus howiana, which is Howe's Chinese bird lizard, and that was described in 2004 by Liu and others based on a second specimen found that had different skull and hip features. However, Turner, Makovicky, and Norrell in 2012 suggested that Sinornithosaurus howiana was a junior synonym of Sinornithosaurus millenii. Another specimen, nicknamed Dave, was described in 2001 but not named. G and others formally referred Dave to Sinornithosaurus in 2002, but said it may be questionable. Stephen Turcas and others said that they thought Dave was a specimen of Cryptovolans pali, which is now considered to be Microraptor gui. Then in 2011, Center said the holotype of Sinornithosaurus was similar to Dave and that Dave was a Sinornithosaurus millenii.
I really like the nickname Dave, especially for a Chinese dinosaur.
It's true. A 2012 paper by Turner, Makovicky, and Norrell agreed and found Dave to be a subadult Sinornithosaurus millenii. The holotype is at the Institute of Vertebrate Paleontology and Paleoanthropology in Beijing, China. In 2009, Ampu Gong and others suggested that Sinornithosaurus was venomous based on its skull. They found it had long and fang-like maxillary teeth with prominent grooves. Long teeth are seen in venomous animals such as snakes, and the grooves provided a channel for the venom, they said. They said the cavity in the jawbone above these teeth may have been for a venom gland. Because of this, they also suggested Sinornithosaurus hunted small prey, such as birds, and used its fangs to stun the prey with this bite and hold strategy. They thought that Sinornithosaurus had a low bite force and used fangs to puncture through feathers, inject venom, and shock its prey. They also said that the teeth at the front of the snout angled forward, which may have been used to pluck feathers. But in 2010, Federico Giannichini and others suggested that Sinornithosaurus was not venomous because the groove teeth are not unique to Sinornithosaurus. They're actually seen in other theropods, including other dromaeosaurids, and that the teeth were not as long as Gong and others thought they were, but that they had come out of their sockets, so they seemed longer. Also, they couldn't find the cavity that supposedly held the venom gland. They only found normal sinus cavities.
But could that just mean that all of these dromaeosaurids were venomous, if they all have similar teeth?
Maybe, but I think we need a lot more evidence for that.
Yeah.
Because we don't know of any venomous dinosaurs.
Yeah, or birds. It's true.
Although, so Gong and his team might agree with you because at the same time they published a reassessment of Giannichini and his team's study, and they said that though groove teeth are common in theropods, mostly feathered maniraptorans, they hypothesized venom was possibly a primitive trait for all archosaurs and stayed in some lineages. They also did not think the teeth were out of their sockets, though they said they were not totally in their natural position. They said some undescribed specimens had full articulated teeth that were similarly as long. However, the consensus seems to be that there's no clear evidence that it was venomous. We need more evidence, basically.
Yeah, it's really hard to prove because almost all that stuff is soft tissue. Unless you have a hollow tooth, if you're using this grooved tooth technique with sort of a venom gland running along the side of the tooth, that's all soft tissue stuff. So then it's really hard to say whether or not it could possibly be there. I kind of hope so. Be interesting.
It would be cool.
And our fun fact of the day is that deposits of the latest Cretaceous, also known as the Maastrichtian, go by many names. So Hell Creek is the most famous, and we often use it as a shorthand for the latest Cretaceous rock in the US. It was the site where Barnum Brown extracted the original T-Rex, although technically he had extracted a Dinosaurus from Wyoming a couple years earlier, which later got synonymized to T-Rex, but it's where the one that got named T-Rex first was found. And there have also been lots of excellent Triceratops and Edmontosaurus skeletons found there, not to mention famous paleontologists who worked in the area. All of this helped to make the Hell Creek really the big name in dinosaur formations. And we already mentioned that there is the Lance Formation as another late Cretaceous formation, but here are some other formations that include the Maastrichtian, also known as the period from 72 to 66 million years ago. In the US, we have the Laramie and Denver formations in Colorado, as well as the Haribel and Ferris formations in Wyoming. Just across the Canadian border, there is the Frenchman Formation in Saskatchewan and the Horseshoe Canyon Formation in Alberta. There's also the Bear Paw Formation in both Montana and Alberta. sort of an international formation. Some other notable Maastrichtian formations around the world include the Maastricht Formation, the namesake of the stage in the Netherlands and Belgium. There's also the Meverano Formation in Madagascar, the Lameda Formation in India, the Nemegt Formation in Mongolia, and a lot of others, some of which aren't completely nailed down between the Maastrichtian and Campanian. The Campanian is one stage older than the Maastrichtian. Also, because they vary in thickness, some of these are only a small slice of time, just like, basically a snapshot of the Maastrichtian, while others span the entire Maastrichtian or even reach into other geological stages, either past the end of dinosaurs or back into the Campanian. Real quickly, I want to mention why we use these different formation names for areas that represent the exact same age of rock. The first is purely practical. They're defined based on their lithology, which is basically a description of the rock. There's the type of the rock. For paleontology, we're basically just interested in sedimentary, because if it's molten rock forming other types of rock, it's obviously not going to hold fossils. With sedimentary rock comes the grain size. It could be in something from a fine shale to much larger grain size like a sandstone. There's also other descriptions like color, texture, and composition, which can be included. And all of this makes it possible to basically look around an area physically when you're on the ground and identify different outcrops of the exact same formation. So you can see the same exact type of rock, see these layers, and then you know that you're looking at things that were deposited at the same time. So you can group the things that you find there together as one fauna. Having formation names also makes updating dates easier because we often refine the age of rock as time goes on. So having a proper noun that we can change makes it a lot easier to read the literature, because if you're saying that's the Hell Creek, and then like when we decided that the Maastrichtian ended a little bit later, we don't have to go back and think, oh, well, at the time we were talking about the Hell Creek and those rocks in Montana, and they were at this age, and now we're going to update the age. We just call it the Hell Creek, and then when the Hell Creek age changes, we know what we're talking about. And finally, it makes comparisons a little bit easier because you can either use similar lithology from different ages or different lithology from the same age and compare what kind of preservation you're getting and what kind of animals you're seeing in different areas. I'm really just scratching the surface of this because I've only studied a little bit of geology, but it's good to keep in mind that many formations overlap when hearing about new finds that are something like the first from a formation, or maybe that it's a new formation from an age. It's kind of good to know these basic principles of formations. Plus, there are a lot more Maastrichtian formations than you may have realized.
It's usually how it goes with paleontology in general.
There's always more to discover.
Yep. And that wraps up this episode of I Know Dino. Thanks for listening. Don't forget to subscribe to us in your favorite podcast app so you don't miss out on any new episodes. And like we mentioned earlier, we're launching 50 dinosaur tales. So for all Tyrannosaurus patrons, you'll get a special signed copy as long as you update your mailing address by August 21st. And if you want to join our book launch team, sign up by August 5th at bit.ly/dinosaurbookteam. Thanks again, and until next time.